hypothesis testing of a population mean using the normal distribution. Example 2. H0, the population mean, is equal to 0.58. The alternative hypothesis H1, we're testing to see if the mean has changed or if the mean is still 0.58 or if it's increased or decreased. This is a two-tailed test. We're using a 1% significance level, and we're starting off with the easier of the methods, the probabilities method. So the data was selected from a population that's normally distributed with this mean, same value there, and this variance. So the standard deviation there is 0.015, the variance is 0.015 squared. So from this normally distributed population, we've randomly selected a sample of size 50, and the sample mean for those 50 values was 0.587. This is our test statistic. Our sample mean distribution, so we have the mean, which is the same, and this fraction here is sigma squared over n. Sigma squared is 0.015 squared divided by n. Now we're going to sketch this normal distribution. So the mean in the center, and we mark on there our test value 0.587. so compared to the mean, it's on the right hand side. So draw a line, and it's from that line going outwards. So we want the probability of this region. So from the calculator, the probability is here. Now in a two-tailed test, we have to split the significance level into two equal parts. So 0.5% on one side, 0.5% on the other side. So we're going to compare our probability here with 0.5% and not the 1%. So I'm using probabilities, I'm not going to use percentages in my comparison here. So that probability compared to 0.005, which is your 0.5%, this is smaller than 0.005, so we're going to reject H0, which means there's sufficient evidence that the mean has changed. Looking at the sketch here, it would be suggested that the mean has increased, but we don't need to state that. We weren't testing for an increase, we were only testing to see if the mean has changed, if it differs from the original value, and we have found a change, and that's all we report in our final conclusion. So part B, this is the critical regions method, so everything is the same initially. So this 1% is split equally into each of these two critical regions. So that would be a probability of 0.01 if you split that, 0.005, 0.005, and 0.99 in the center. The mean. So we now need to work out our critical values. So the cumulative probability to the left of this line is here. The cumulative probability to the left of this line is this plus this, so 0.995. We're going to use those and use the inverse normal distribution on the calculator to work out these values. It's a simple process. So we get our critical values. So this critical region here is for values less than or equal to 0.574, and this critical region here is for values greater than or equal to 0.585. Two tails, hence the two-tailed test. Our test value is 0.587, and 0.587 is in the critical region, so we reject H0. Sufficient evidence that the mean has changed. If you're given more for context, you have to use it in your conclusion at this stage. Other things to remember in hypothesis testing: your null hypothesis, it's always whatever parameter you're testing. We're testing a population mean, so make sure you're using the correct symbol, and this is always equals in the null hypothesis. In the alternative hypothesis, you have the same value, but this could be less than, it could be more than, or not equal to, depending on what the test is. This is also meaningless. H0 equals 0.58. It doesn't tell you what parameter you're testing. There are so many statistical parameters that we can do hypothesis tests on, and there's nothing suggested here now, so this is wrong. This would score 0 marks. For practice, try these questions.